Hello, I'm making this video in order to help you with project number 2, which is on neural encoding. And here you see the slides we had that are in fact entitled 6-point neural encoding .pdf. So in the class we had seen this pioneering work from Georgopoulos, and in fact I uploaded his 1982 paper into the assignments under Project 2. It's also under files, Project 2 files on e-learning. So for this project, you have a MATLAB file, project2.mat, and what it has are recordings from 2 neurons. So someone has spike sorted these neurons for us. So we have the exact times that they're firing. And these were recorded from a primate who was performing this classic center out task. So the primate was trained to be able to control this manipulandum. It sees an LED first turn red in one of these 8 directions. And once the LED turns green, that's his go cue. And starting out from the center, it has to hit that target in a certain amount of time. So for these recordings, all the trials are correct trials. So the ones where the primate didn't perform well were thrown out. And the first thing you're asked to do is create a raster plot like this. Okay, so these raster plots have separated these trials in all of the 8 directions. Okay, so that's what these 8 directions represent. And all of these, tiny little bars are each when a spike was recorded in a given trial. Okay, so every row is a different trial, and for this is in minus 45 degrees or in direction 8. Okay, so we're looking at 1 second before and 1 second after the go cue for this trial, and we're interested in the firing patterns with respect to this onset in this direction. And then you basically replicate this for all of them, and you can visually see that this neuron really had a preferred direction in this quadrant. Okay, so let's take a look at the data really quickly. So I'm loading Project2.mat, and when you do that, you will see in your workspace that you have now 3 variables, and these are direction, go, and neuron. So direction and go are, as you will see, are column vectors, and these represent all the trials. So there was a total of 158 trials in which the primates correctly hit the target. And it is in the project description, but I got these 2 neuron recordings from the Hatsopoulos lab, which made them available. And Dr. Nico Hatsopoulos' lab is at the University of Chicago. Okay, so for instance, if we take a look at the first trial, okay, and see what the direction 1 and go are. So direction 1, or the direction for the first trial was 3. What that means is that for the first trial, the primate basically moved the manipulandum in 90 degrees, or straight forward. Okay, and the go cue was at 16.3 seconds. That means basically, it received its first cue at that time. So for instance, let me actually maybe write trial is 2. Let's repeat this with trial instead of hard coding it every time. Okay, so in the second trial, the direction was 5, so to the left. And that command happened at 27 seconds into the experiment. Okay, so let me Okay, and then let's take a look at what neuron is. So neuron is a structure. Okay, so it is a 1 by 2 structure with array of fields times. Okay, the reason why I made this a structure instead of, well, these were only 2 neurons, so I could have basically just called neuron 1 is neuron 1 dot times, and if you want, you can just do this. Neuron 2 is neuron 2 dot times. The reason why I just wanted to put them in a structure, if I had basically more than 2 neurons, many neurons, and I just wanted to, store all their spiking times in one variable, having a structure with basically multiple, indices or multiple, arrays allows you to store things that are of the same nature, so in this time, these are spike times, these are both going to be vectors of times, but they aren't necessarily of the same length. For instance, if we go to the workspace, neuron 1 fired, 9,500 times, whereas neuron 2 fired 11,000 times. Okay? Again, this is just to show you, what else there is out there in MATLAB. So a structure really allows you to, store things that will have the same field, but maybe will have different dimensions for those fields. And you might have things with, more fields. For instance, I could have said, how the field saying area. So neuron 1 dot area, and I could have write M1 as the primary motor cortex. In this case, both of these neurons are in the primary motor cortex. So that's not going to be helpful. I don't know, maybe neuron 1 dot date or something like that. But in any case, if you just, not want to deal with this structure over and over, you can just, have 2 new variables and call them neuron 1 and neuron 2. Okay, so neuron 1 times are basically all the times in seconds that neuron 1 fired, and similarly for neuron 2. So let me switch to the project description. So this is again available on eLearning. Let's see. What I'm asking you to do is basically create that raster plot. And this is the hints that I'm giving you. So if you have a for loop that goes through all your directions,